Hello, everyone. My name is Chris Navratil. I am the new Clean Technology Innovation Lab coordinator. And in this video, what I wanted to do was just introduce the new lab, some of the aspects of what the students are going to be experiencing, some of the really exciting projects that we've already been working on, and then I also wanted to share some of the future aspects of the lab. So I did want to start off just by talking about what exactly is clean technology versus just a regular technology classroom. And it's pretty simple. It really is just technology that doesn't necessarily make a huge mess. We are going to be fixating on some areas of equipment that the students might not necessarily get as deeply involved with in the regular technology courses. And I'm going to share all of these different pieces of equipment with you briefly in this video. So we do currently have 3D printers, laser cutters, a CNC machine, a vacuum former, vinyl cutters, a huge printer, plotter, and also a heat press. Now, this is not all encompassing. We also have access to other things as well, but these are kind of the big hitters. So what is the purpose of the Clean Technology Lab? At the moment, my fixation is having students get and gain an experience on the many different types of forms of equipment that we now have available in this lab. And that involves not only the design process, but the operation of those pieces of equipment as far as we can get them involved as possible. The design portion is really going to be encompassing kind of 2D and 3D. The 2D designs lend themselves well to certain things in the lab as opposed to others. So if we were going to be doing a two-dimensional design that would encapsulate more of a vinyl cut, like a sticker or a decal, and the laser cutting, whereas if we were going to be doing something in 3 dimensions, that would lend itself well to the 3D printers. So speaking of 3D printers, we did just get our Prusas, and they showed up about a month ago, and we did our first project with the students, and they had an absolute blast doing this. We all custom designed our own keychains. So the students were given constraints on the size of the keychains, the outer dimensions, and the fact that it did have to have a hole so that it could function as an actual keychain. The inside was completely up to them. They were creative with it. A lot of them chose to do their names or family members' names or emoticons, and we had a couple of students who even went as far as to kind of bust out of the given constraints and create other objects as well, which was really, really cool. This is actually only showing about maybe a third of the amount of keychains that we printed in about a week. For the laser cutting, currently our laser cutters are still awaiting a proper exhaust system that will be installed in the new lab, which I'll be sharing closer to the end of this video. But I do have a couple pictures of just projects that are going to be upcoming with that. In the past, I have had students design and create their own houses. And this was all done on a flat surface. So in other words, in geometry terms, it would be a net that folded together to create their house. And going forward from there, I'm thinking of having students design their own clocks. We could delve into the world of aeronautics and creating their own planes, and we could do architectural engineering in terms of making bridges and custom boxes, which could lend itself well to a various amount of different projects. For the CNC router, again, one of the pieces of equipment that we are still waiting, it is in need of a 220-volt hookup, which the new room will supply for us. But when we do get there, one of the big projects we're going to be fixating on is creating a marble maze that the students are going to completely design custom themselves and then cut out. And the CNC router, I mean, the possibilities are really endless. You can do all sorts of different things. Just a couple other examples, a desk organizer that the students could create, or as far as if students get really involved, we could even do furniture design with CNC routing. For the vacuum former, we have delved a little bit into this so far in our first couple sessions. The couple projects that I'm going to be introducing them to with the vacuum former is creating 3D models on the 3D printer, and then using those models for the vacuum former, which essentially gets it's a kind of a malleable piece of plastic that gets heated up, and you push it down over a mold, and the vacuum actually kind of sucks out all of the air. And then if you let that plastic dry, you are left with a mold of whatever object you put in the vacuum former. So going forward, I can have students take a look at doing packaging design. So if they were to develop a product and 3D print it, they could then design the packaging that could go over that. We're going to be taking a look at creating our own terrariums through molding of the bottom, either cast in plaster of Paris or with concrete. And then they can design their own little world that goes in the inside, and the top piece is actually another vacuum form mold as well. And the students are all very, very excited at the moment. We are in the process of taking a look at using vacuum forming to create molds so that we could make our own chocolate, custom chocolate. For the vinyl cutter, we actually have two in the lab. We have kind of a professional grade 2 foot wide by 25-yard roll of vinyl cut, so we could make very, very large decals. The idea behind this is if the school is in need of some type of large decal, we could commission students to create design and then actually cut that out on the vinyl cutter that's in the classroom. We have used it so far to create many, many custom stickers. We have done this with 6th and 8th graders. Both grades absolutely involved and loved it. Here's a picture of just a couple that were created. Again, these were custom designed by a student, cut out, and then placed on their Chromebook. Just a couple other examples of where we could go with vinyl cutting, doing decals for glasses, or kind of using it with the back of laptops in a creative way. We also have the large plotter, which essentially is a printer, but it has a 3 foot wide printing area, again, by 50 yards, something along those lines. In the beginning of the school year, we were in need of a new school store poster, and the student here had completely designed this from scratch, and we were able to print it off on the printer, which was very exciting. So that was some of the equipment and some of the things that we're going to be taking a look at in the lab. What I'd like to do now is share a 3D model that I've created of our new lab. So at the moment, as I was mentioning, the laser cutter and CNC router do not have the proper hookups. So what we're going to be attempting to do is move the lab to a different area of the school, which would be room C158. This is just a rendering I've created of that space. There's actually kind of 3 rooms, 1 large instruction area. This will be more of our lab workspace area. And then in the back of this lab will be our CNC cutting. So out this window will be the dust collection system for that CNC router. And inside here we'll house all of our 3D printers, our very nice new makerspace workbenches, our vinyl cutter, our heat presses, our laser cutters. So the students will be able to take their designs and go into this room and then manipulate them in a way that actually works for them. So this is just kind of the idea for the setup for the new lab as we move forward. I would also like to share, I've been working pretty diligently on a website for our clean technology innovation space. So if I just go here to the home page, this is just a little bit of the overview of the actual space, a little bit about myself. And the idea behind the website is to have documentation for all of the pieces of equipment that the students are going to have access to. I will provide them with the manuals, instruction videos, and as the website gets developed, there will be videos that will go over exactly how to operate those on their end. And hopefully, I would like to see some of the students actually direct and film and then edit these videos for other students to use. Also, I have a page dedicated to just tutorials with the different types of software that we've been using. So far this year, we've been heavily using Tinkercad and another 3D modeling program called Onshape. And all of these links bring the students to YouTube videos on the tutorials for how to do certain things in all of those programs, kind of keeping it nice and neat. And as you can see, this is still very much a work in progress, but as the amount of programs that we're going to utilize grow, the tutorial videos will as well. And I've also recently come up with an idea of creating something called the Master Creator Program. And the idea behind this is to have students kind of have a goal to work towards for the 6 weeks that they're in the Innovation Lab. The Master Creator Program basically will be a checklist of items that they can become proficient in. So if we take a look at the checklist that they would eventually fill out, again, not completed, but essentially they would look at a video or a tutorial for the introduction to Tinkercad, and attached would be some type of assessment. And if they were able to complete that assessment with a certain level of accuracy, they could then take a screenshot of their score and upload it to a link to this actual one introduction area here. And then they could move forward to the next tutorial, the next assessment, and so on and so forth. I have started to color code these, as some of them would require a screenshot of an assessment, while others would actually require a screenshot of the actual product that they designed. This will become a full-on checklist with all of the different software, all of the different pieces of equipment, and if they are able to complete all of that within the given 6 weeks of the lab, they would then be awarded with the Master Creator certificate. So these are ideas that are still in motion, trying to complete them as we go along, but the students are very, very excited to be in the lab. Thank you so much for watching. Have a good one.